Severe dust precipitation in the United Kingdom in April 1st through 2nd, 2014 were caused by the Sahara dust storm. Dust was blown from the Sahara in Algeria across mainland Europe, precipitating in the United Kingdom, creating a threat to human health. This animation will help you understand the dynamics of the Sahara sandstorm. Here we see London in April 1st and 2nd, 2014. Almost no visibility due to air pollution from the Sahara dust storm. The elderly and people with health problems were advised to stay indoors and take special care. Asthmatics complained of sore chests and breathlessness. The commuters used face masks to avoid inhaling the particles. This map shows the southeastern portion of England that experienced high levels of air pollution. Pay special attention to the pink, red, and violet colors. These are the areas where people suffered from sore eyes and throats and were advised to reduce their outdoor activities. One more example of a severe dust storm that swept over Sydney, Australia in September 22nd and 23rd, 2009. The sky became red because of a high concentration of oxidized iron in the sand dust. People with asthma and other lung conditions were advised to stay indoors. Health effects of the September 2009 dust storm in Sydney was investigated by scientists. They found that the dust particles contained high iron-aluminum ratio equal to 9. This number is significantly higher than the typical Northern Hemisphere values, approximately 0.45 to 0.6. The dust contained elevated pollutants such as particulate matter ranging from 2.5 to 10 parts per million and contained extreme levels of 3-valent iron and nitrogen oxides. Strong sandstorms delivered dust from Sahara to the U.S., particularly Florida. Each year, over 100 million tons of Saharan dust gets blown across the Atlantic, some of it reaching as far as the Amazon River basin. The minerals in the dust replenish nutrients in the rainforest soils, which are depleted by tropical rains. This diagram shows bulk chemical composition. In the dust originating in the Sahara Desert, there are 10% iron oxide, which serves as micronutrients for the marine environment. The Gobi Desert is another geological source of abundant dust storms blanketing northern China. The Gobi Desert is situated along the border between China and Mongolia. It is one of the world's most abundant sources of dust. The Gobi Desert occupies 1.3 million square kilometers of the Earth. The Gobi Desert is built up with massive rocky areas, large dry grasslands, and sand. Small bodies of water also occur in the desert. Increasing agricultural activity in the Gobi area threatens to detach much of the sand and topsoil in the desert, which could be swept away by the winds. This process is called desertification and is common in many deserts around the world. This image from NASA shows dust plumes which blew out of the Gobi Desert in late April 2012. The dust moved southwest, blanketing Beijing and surrounding territories of northern China. The processes of desertification are extending the Gobi Desert area, and the desert is getting closer to Beijing. The dust storms dramatically affect the visibility in Beijing and contribute to air pollution. How fast does an intercontinental dust storm move? This satellite image shows the sandstorm which starts to move from the Gobi Desert, Asia, to North America, April 15 through 18, 1998. April 19th, the Gobi Desert dust storm left the continental part of Asia, and by April 21st, it was crossing over the Pacific Ocean. By April 25th, it reached the Pacific coast of the United States. It took 6 days to transport dust from the Gobi Desert to the Pacific coast of the U.S. Now prepare for a quick quiz.